Hi.
We can use this right now.
Yeah.
What?
I don't. She had other things going on.
No,
Okay.
I just really didn't like it.
So last time we did mole-to-mole stoichiometry last time, where we just used the molar ratios to go from one reactant to a product or from one reactant to another reactant. And you guys did that in your reading guide. Now we're going to do mass-to-mass stoichiometry because it is not very practical to start out with moles. We can't weigh moles in the lab. We can only weigh out grams. So we have to know how many grams we start with and how many grams we end up with in a chemical reaction because moles don't really help us out that much. So what I want you to do with your group is I want you to read these paragraphs, or just these two sections, aloud. So you're going to read the rest of this page and then flip it when you're done. That way I know you're done. Okay? Reset, go. Okay, so what we're going to do with mass-to-mass stoichiometry problems, they're not much different than mole-to-mole stoichiometry problems. You still have to balance the chemical equation because that's like your basis, is like your recipe on how you're going to create something. But the only thing that you have to do differently is you have to get everything in terms of moles. Because your balanced chemical equation, like A plus B yields C, these coefficients out here are in terms of moles. So you've got to get everything to molar ratios in order to solve for things in a chemical equation. So you go from mass to moles, then you apply your molar ratios, and if it asks for grams or asks for a mass at the end, you'll go back using molar mass to solve for grams. So the best way to show this is by doing an example. So, it says translate the following word equations to a chemical equation, balance, and solve for the questions given. Lithium hydroxide reacts with hydrogen bromide. So lithium hydroxide plus 1 reacts with hydrogen bromide plus 1 minus 1. What kind of chemical reaction is this? Double replacement, yeah. So this is going to be lithium bromide plus HOH. What's HOH? It's water, yeah, H2O. So now we have to balance. And I think this is already balanced. I think I have two hydrogens, one oxygen, lithium bromide. So the good news is these are all 1-to-1 molar ratios. So it says if you start with 0.68 moles of hydrogen bromide, how many moles of water will you have in your products, and how many moles of lithium bromide will you have? So this is just going from moles to moles. So you're given moles, so all you have to do is use the molar ratio. So for every 0.68 moles of hydrogen bromide, you've got to get rid of the units of hydrogen bromide and get them into terms of water, first of all. So for every 1 mole of hydrogen bromide, you have 1 mole of water, according to like your quote-unquote recipe, your balanced chemical equation. So your moles of hydrogen bromide cancel, and you get 0.68 moles of water. So this is called a 1-to-1 molar ratio. If your coefficients are the same, then your number of moles will be the same. And then it says how many moles of lithium bromide do you have? I can push you through the pain of doing dimensional analysis again, but this is a 1-to-1 molar ratio. So for every 1 mole of hydrogen bromide, you're going to get 1 mole of lithium bromide. So I'm just going to write it. So there's a refresher of mole-to-mole stoichiometry. So now we're going to crank it up a notch. If you start off with 0.68 moles of hydrogen bromide, how many grams of lithium bromide will you produce? And then how many grams of water? So again, starting from the beginning with 0.68 moles of hydrogen bromide, that's what they give you. And you are trying to get to grams of lithium bromide. So in order to get to grams of lithium bromide, we have to know how many moles of lithium bromide we have. So according to our balanced chemical equation, for every 1 mole of hydrogen bromide, you have 1 mole of lithium bromide. But the question is asking for grams of lithium bromide, and we're stuck at moles. Now what? Molar mass. You guys say that with such sadness. I don't know where my calculator is. No, she didn't. Okay, so lithium is 6.94, bromine is 79.90. So, for every 1 mole of lithium bromide, it is 86.84 grams of lithium bromide. So your moles cancel, and you're left with grams of lithium bromide, which is what you wanted. So 59.05 grams of lithium bromide. Okay? So that's step 1. We went from moles of hydrogen bromide to grams of lithium bromide. Now I want you to do the next step. So start with 0.6 moles of hydrogen bromide and go 2 grams of water. So you're going to follow the exact same steps, only you're solving for water. So you need to get your molar ratio from moles of hydrogen bromide to moles of water here. Okay, let's try that out. Okay, so now we're starting with grams, and we need to get to moles of lithium bromide and water. And then later, we're going to solve for the mass of both lithium bromide and water. So starting with 0.68 grams of hydrogen bromide, I cannot do this next step here that I did previously. I cannot do my mole to mole ratio because I'm not in terms of moles yet. So every time you are given a mass, you have to change it to moles so that you can use your mole to mole ratio in your balanced chemical equation to solve for other compounds. So for every 1 mole of hydrogen bromide, bromine 79.9, hydrogen's 1.01, so this is E.91 grams. So now that your grams of hydrogen bromide cancel, you are finally in terms of hydrogen bromide moles, so you can use your molar ratio from your balanced chemical equation to solve for the rest of the problem. So for every 1 mole of hydrogen bromide, let's solve for lithium bromide first. So for every 1 mole of hydrogen bromide, you produce 1 mole of lithium bromide. And this will tell you how many moles of lithium bromide you have. So 0.68 divided by 80.91 gives you 8.4 times 10 to the negative 3rd moles of lithium bromide. So go ahead and do the same thing with water. Start with 0.68 grams of hydrogen bromide and get 2 moles of water. So, if I give you volume and molarity instead of mass, you're still going to have to do the same thing. You still have to get this in terms of moles. So it says if you start with 120 milliliters of 0.68 molar hydrogen bromide, what is the concentration of lithium bromide that you will produce? So we need to get this guy 2 moles, and we're using the same equation as before. So hydrogen bromide plus lithium hydroxide gives you water. So we're continuing this chemical equation. So if you are given 120 milliliters of 0.68 molar hydrogen bromide, you're given 0.12 liters, and in every 1 liter of hydrogen bromide, there's 0.68 moles, just like the test you took, just revisiting the past. So now you're in terms of moles of hydrogen bromide. Once you get your only unit left over to be moles of something, then you can start doing stoichiometry. So for every 1 mole of hydrogen bromide, you're going to get 1 mole of lithium bromide. So this will tell you how many moles of lithium bromide you have, but it's not going to tell you the concentration yet. So we'll just solve for this first. So 0.12 times 0.68 equals 0.0816 moles of lithium bromide. But it's asking for concentration, and concentration is molarity, which is moles per liter. So there's my moles. And then it says, assume the lithium hydroxide volume is negligible. So assuming that I add something, my volume is not going to change. So the volume of my reaction is 120 milliliters. So just divide this value by 120 milliliters or 0.12 liters. And that will tell you the concentration of your product. So 0.68. Look at that. That number keeps showing up all over the place. So you can either write 0.68 moles per liter or 0.68 molar, the capital M. All right, I'm releasing the reins. So I want you to balance question 2 and do parts A through, just do the rest of the page. But don't do question 3 because I made a typo. So this question will bring you to the end of the page. So go ahead and work together on that. Here's the balanced chemical equation that you should be working with, and these are your molar ratios. If you're starting with grams, if you're starting with 5.5 grams of solid aluminum, you have to get that to moles. And when you solve for the number of moles, you don't change the way you solve molar mass. Molar mass is always out of 1 mole of aluminum. So there's 26.98 grams in 1 mole of aluminum. I know that in your chemical equation, you have 2 moles of aluminum, but that comes into play when you do your molar ratios. So for every 2 moles of aluminum, you started out with 2 moles of aluminum acetate. So that's where the 2 moles come in, not with the molar mass. And now, the only thing left over is moles of aluminum acetate. So you need to figure out how many grams of aluminum acetate that is. And molar mass is out of units of 1 mole. I know you have 2 moles in your chemical equation, but you already took care of that math during the molar ratio, so you don't have to do it twice. So the molar mass of aluminum acetate, it's a big one. 26. Plus 32. I got 204.13. So this will tell you how many grams of aluminum acetate came from 5.5 grams of aluminum. So I got 41.61.
You got that's basically what we did.
So, do the same thing for magnesium. I also want to know how many grams of magnesium did you start with. So start with the 5.5 grams of aluminum, go to moles, and then do your molar ratio according to magnesium this time.